All right, so here we go with these notes. So first we have to remember from Algebra 1 how to reduce square roots. And so you might have learned the birthday cake method, or, breaking it down. So we're going to do that, or you can still do that, but I want you to realize something that makes your life a little bit easier and faster. All right, so on your multiplication chart, these numbers down the diagonal here, those are your perfect squares. And when you take the square root of a perfect square, you get a perfect answer, right? Like the square of 36, right, is 6. The square root of 121 is 11, because those are all the numbers, because obviously a square root is what number times itself makes that number. So these are the numbers that we're going to want to get out. Like if you think of the number 72, 72 is 36 times 2. So basically what you can say to yourself is, oh, that's just the square root of 36 times the square root of 2, because that comes together and makes 72. I know this is 6, so I'm going to say 6 radical 2. Okay, so that's what we're going to be trying to basically do here. All right, so let me get a different pen because this one is not working good. All right, so when I look at 18, I think to myself, yeah, 18 is 6 times 3, but that doesn't help me because 6 and 3 are not perfect squares. So if I think of 9 and 2, that's much faster. So 18 is 9 times 2. I know the square root of 9 is 3, so I'm going to write 3 radical 2. Okay. 75. 75 is like 15 times 5, but no, that's not helpful because it's not, they're not perfect squares. So, but if I think of this 25 times 3, then I'm like, okay, well that means 5 comes out, radical 3 stays there. All right, 40, 4 times 10, yeah, and you can break it down that way, but if you think of it, oh yeah, that is the one, 4 times 10, sorry, I talked myself out of it. So yeah, so if you think of 4 times 10, and 10 is only 5 and 2, and there's not going to be nothing left to take out of that, so I can think 2 radical 10. Okay, now it turns out, let's say you get a big number and you're like, I'm not sure which perfect square goes into that. You could grab your calculator and you could start trying. Like 80 is an even number, so you could be like, okay, 80 divided by 4. Yes, that's still pretty big. So 80 divided by the next thing, if 4 goes in, then maybe 16. And so, oh yeah, that's it, because 16 times 5, so I get 4 radical 5. Now, if you don't have a calculator or whatever, you don't want to do that, you can still break it down, right? So let's see, 80, maybe I think of 8 times 10. 8, 4 times 2, and then finally 2 times 2. And then 10 is 2 times 5. So what I notice here is that I have a pair of 2's and another pair of 2's. So if I'm bringing out 2 2's, 2 times 2 is 4, and the 5 is staying inside untouched. So that would be the same thing as if I thought of 16 times 5 for 80, right? Okay, 72, we just did that one earlier. We knew it was 36 times 2, so that's 6 radical 2. Okay, so there's just going to be things that you have to do, all right? All right, 12 or 120. I can't really think of one here. 60 times 2, I think I'll go with. 60 times 2, and then I got 30 times 2. So I'm going to stop there because 30 is 5 and 6, and then 6 is 3 and 2. So that's not going to produce anything for me. So I think I'm done right here. I'm going to bring a 2 out with a radical 30. And just a last check, 30 is 5 times 6, and 6 is 3 times 2. If I had a 5, 3, and 2, nothing would come out of that. So that's finished. Okay, well, square root of 25, hopefully you know this is 5. I just stuck that one in there just to... All right, radical 112. Let's see, 112. Well, 50 times 2 is 100. And then 6 times 2 is 12, so I'm going to do 56 times 2. All right, and 56 is 8 times 7, right? Yep. All right, so 8 times 7. All right, 8 is 4 times 2, and I got 2 and 2. So I got a pair of 2's here and another pair of 2's there. So 2 2's is 4, so I'm going to say 4 radical 7. Now, if you want to check if you're right, you can do this. This 4 right here, if I square it back, it'll be a 16 on the inside. So if I check 16 times 7, yep, 112. Okay. All right, 250. Let's see, let's use 25 times 10. Right, that's the biggest perfect square that goes into it, so 5 radical 10. And 8, that's an easy one. 4 times 2, 4 is a perfect square, so it's going to be 2 radical 2. Okay, so hopefully you remember that from Algebra 1, but hopefully, get a little faster at it. All right, down here, so we're going to be using that. These answers, if you recognize them, remember the good old quadratic formula? These are what your answers are going to look like eventually, so I want you to know how to reduce them. So when I look at this problem, square root of 64 is something that I know is a perfect square. So I'm going to get 4 plus or minus 8 all over 2. And it's important, this fraction is over both of these numbers. So I'm going to go ahead and figure out my answers. I got 4 plus 8, that's 12 over 2. And then I have 4 minus 8, which is negative 4 over 2. So my two answers are 6 and negative 2. Okay, and when you're on your delta math, when you have two answers, if you type in the first one and then put a comma, it'll make a space for a second answer, so just in case. All right, this one, 75, I don't know the square root of 75, it's not perfect, but I do know that 75 is 5 radical 3, so I'd have to figure that out on the side, but I have it up top, so negative 5 plus or minus 5 radical 3 all over 10. Now, if you notice that these three numbers, so it has to be all three, these three numbers all divide by something, go ahead and divide them. It has to be all three. You can't touch this guy, but these three, they all divide by 5. So my final answer would be negative 1, because that divided by 5 is negative 1, plus or minus, this is also a 1, but I don't have to put it because I can just put the radical 3, and then over 2. So there's my final answer. All right, over here, 72 we did earlier, but I would basically have to do this work on the side. So this turns into 8 plus or minus 6 radical 2 all over 4. So once again, these three numbers, they all divide by 2. So do that to reduce it. So I get 4 plus or minus 3 radical 2 stays over 2. And there's my answer. Okay. And this also can be split up into 4 over 2 plus or minus 3 radical 2 over 2, and then I can reduce this, but don't do that yet. We'll just, this is fine for us right here. Okay. All right, over here, 80. Oh, we did that earlier. Yep, we got 4 radical 5. So I got negative 4 plus or minus 4 radical 5 all over 4. Oh, all three of these 4s, they all divide by 4. So I'm going to get negative 1 plus or minus and 1 radical 5, so I'll just put radical 5, and over this would turn into a 1. So do I really need a fraction that's over 1? No, so I'll be finished right there. All right, oh, another perfect one here, so I get 5 out of that, so I get negative 1 plus or minus 5 all over 3. So let's figure out our two answers. Negative 1 plus 5 would be 4, and 4 over 3, and negative 1 minus 5 would be negative 6 over 3. So 4/3 doesn't reduce, so I'm just going to say 4/3, and this reduces to negative 2. All right, 200. We didn't do that up top, but I know that 200 is 100 times 2. So I'm going to bring out a 10 and leave a 2 inside. So we get 2 plus or minus 10 radical 2 all over 8. So these three numbers don't touch him. All right, those three numbers divide by 2. So I'm going to say 1 plus or minus 5 radical 2 over 4 is my final answer. Okay. All right, so you're going to get these answers from problems like this. So hopefully you remember from Algebra 1 that when you have a quadratic equation, ax squared plus bx plus c equals 0, and those could be minuses, whatever, but you can solve it using the quadratic formula. Okay, but you get your a, b, and c from that. And one little special thing, this item in here, the part underneath the square root, the part inside without the square root, this b squared minus 4ac, that is called your discriminant. And it's basically the hardest part to figure out, right? Because you can do negative or opposite of b in your head, you can do 2a in your head, but that's the annoying part. So we want to figure that out also when we're doing our problem. So I have a, b, c, and d. So let's write down ABC, 7, 5, so you don't take the x's with you because we're just looking for the numbers in front of these things. And negative 1, make sure you put your negative. Now my discriminant. So I'm going to ask you to do some things in your head. Like for instance, b squared, all right? All right, I can square 5 in my head. So my discriminant is 25 minus 4 times a is 7 and c is negative 1. And then you just pop that in your calculator, right? So we got 25 minus 4 times 7 times negative 1. All right, 53. All right, so when I'm done with that, what's the hardest part to do? So my answers, big fraction, opposite of b, so negative 5, plus or minus square root of 53 over 2 times 7, which is 14. Okay, and radical 53, 53 is a prime number, I'm finished. So some of your problems are just going to be done like that, and then a lot of them are, and some of them take reducing, but that would be it. All right, here, a is 1 because there's a 1x squared, negative 4 and negative 8. And again, do some of this in your head. I need b squared minus 4ac. So negative 4, when I square it, is 16, right? Because basically you're doing this, negative 4 squared. So the negative is going to go away. So I got 16 minus 4. A is 1, C is negative 8. So I'm going to pop that in my calculator. Now, what people will do, and they'll do it wrong, is they'll do this. They'll do negative 4 squared. That's not what this problem is asking for. It's not negative 16. All right? It's parentheses negative 4, and then a square. That's positive 16. All right? I see people make this mistake all the time. They will type in negative 4 squared minus 4 times 1 times negative 8. And I don't need the 1 there, obviously. All right? And they'll just get it wrong, okay? Because this is not correct. All right? You have to put parentheses around it. But that's why I say do it in your head. I mean, you can do 4 squared in your head, right? Who cares about the negative? Because you're squaring it out. So 16 minus 4, I'm not going to put the 1 times negative 8. All right, so 48. All right, so x equals opposite of negative 4 is 4, plus or minus radical 48, all over 2. 2 times 1 is 2. All right, so 48, I do have to work on that a little bit, right? So 48, let's see. 48 is 16 times 3. So you might try, 48, let's divide it by 4. Yeah, 48 divided by 16. So just try dividing some of your perfect squares and you see, oh, it's 3. So that 48 is going to turn into 4 radical 3, all over 2. All right, these all divide by 2, so I'm going to say 2 plus or minus 2 radical 3. I would put over 1, but why bother? And you shouldn't. All right, last 2. So I got 2, negative 2, and negative 5. I'm going to go ahead and do my discriminant, b squared, so that would be 4 minus 4 times 2 times negative 5. Now, if you don't have a calculator around, you can kind of do this in your head. You got 4, get 2 minuses, so that'll be a plus, and 8 times 5, basically, so 40. So it's 44, right? So I got negative b, square root of 44, over 2 times 2 is 4. Okay? Right, so you can do it in your head, but... All right, 44, that's 4 times 11, so I'm going to be able to reduce this. So 2 plus or minus 2 radical 11, all over 4. I'll reduce these by 2. So I got 1 plus or minus 1 radical 11. So I don't need a 1 here, but I do need it there. All right, over 2. All right, and then last one. So I got 2, 3, and negative 20. So my discriminant, b squared, is 9 minus 4 times 2 and negative 20. All right, so I got 9. 2 minuses make a plus, and I get 8 times 20. So that'll be 160. Or use your calculator. So that's 169. 169 is a perfect square. It's 13. Or 13 squared is 169. All right, so here we go. So I got negative b, so negative 3 plus or minus square root of 169 all over 2 times 2, which is 4. All right, so I get negative 3 plus or minus 13 over 4. All right, so I have some figuring to do. I got negative 3 plus 13. Well, negative 3 plus 13 is 10, and 10 over 4. Well, 10 over 4 reduces to 5 over 2. All right, and then negative 3 minus 13, that's negative 16 over 4, and then that's negative 4. All right, so my answers would be 5 over 2 and negative 4. And 5 over 2 is 2.5, but just leave it a fraction. And there you go. So just real quick, on the back here. If you need to do any scratch work for there's like quite a few problems on simplifying radicals on the Delta Math like this. So if you just need to do any scratch work, do it there. There's 5 problems where I'm just asking you to find the discriminant. So literally I'm asking for like this number or, you know, that number, just finding the discriminant just to practice that. And you do get a few tries on these, like if you get it wrong. All right, and then down here, there's enough space for you to do the quadratic formula for these problems. So that'll be that. And turn this into the substitute when you're done. All right, bye-bye. Be good.